Hey, well, thanks. It's fabulous to be here, this wonderful event with everyone. And I'm reminded that the last time I was invited to Berlin to speak I actually was here on the day that the wall fell. It was quite a thing. And maybe some of the announcements I'm going to make here today will have some potentially profound significance as well. I think, back in those days, I was concerned about personal privacy. That was my focus, and it had to do with digital sovereignty. But the issue that was prevalent was personal privacy. And so what I did was I found a whole kind of messaging, payments, and identity/reputation technology suite that provided a comprehensive way for people to live in cyberspace while maintaining control of their personal information. And I proposed that and appeared in a lot of publications, and there was a lot of interest in it, but as it's obvious that was a bit early. It was actually pre-web, if you can believe it. And I anticipated, if you read the Scientific American article, you can, let me, without getting too deep into history, I would refer you to a recent one-hour keynote I gave where I put all this information into perspective. It's up, and it was in Zurich, and I urge you to have a look at it if you're interested. But I think now the situation's very, very different because, while we were concerned about privacy, and then there was outrage that some of these major corporations were exploiting information about us for their own monetary gain. I think few were aware of the real elephant in the middle of the room. The real problem was that these corporations are basically stealing control over not only society but nation states from us by using this information to manipulate us. And this is obviously an even far more important and profound issue. And amazingly, the general public has become pretty much aware of this. So all of us that have worked for many years as more or less volunteers to build out information technology, we've created something that's maybe a big problem. So I think that we now, at Praxis, we have found a way to turn this all around and use the power of cryptography and digital technology to change the situation dramatically. And I'm going to walk you through that briefly here. So it was less than a year ago that we announced our effort, and I spent a lot of time traveling around and, building up a team and addressing community. And we've got, you will hear more about it, but we've got a beta node program. But I think we've got several thousand people using our waiting list app and the AlphaNet messaging system will be coming live in a couple of weeks, and I'll come into that. And now another thing is that we're announcing at least the coming out of stealth of a major breakthrough project here today. So this is kind of what we've accomplished in a year. We said we would come out with this thing, and now we've actually got it running, and we're going to be announcing this breakthrough. So essentially, we're trying to give control over people's informational lives back to them, and a necessary condition for that is control over metadata. We have to get rid of the metadata. If you can collect information about the complete social graph, when and every message is sent to whom and from where and to where and so forth, then it's very difficult to protect information about individuals. You've already lost the game. So if we can protect the metadata or shred it, then we have a chance at digital sovereignty. So there are really 4 requirements in order to make a system that can basically replace the WeChats and Facebooks and so on of this world, Alipay's, right? Because we have to be able to do messaging integrated with payments. That's what consumers want. That is the killer app globally, and that's where all this metadata is captured. So how can we do that? We need to be able to provide messaging or payments in less than 10 seconds per transaction, from initiation to completion or finality of payment, so that both parties know the payment is irreversible. And we have to shred the metadata, and there's 2 aspects of that which I think you might find helpful to think about. One is the horizontal, well, I should say here, the obvious one is the vertical, the linking of your IP address or your phone's MAC address to a transaction. However, there's another kind of linking that people in this space have found out about, which is the linking of transactions to transactions, the linking from wallet ID to wallet ID based on even just the exact amount of payment. That horizontal linking is also almost sufficient to find out the metadata. So actually, solution to both of these is needed, but if we can get rid of the horizontal, that's a big step forward. And of course, we have to be able to support transaction speeds and capacities that are commensurate with widespread consumer use. So we're talking about like 100,000 messages in a batch every few seconds, up to perhaps 1 million. We need that kind of capacity. And there's a final requirement which most people in the community aren't really that attuned to yet, but the real threat is nation states. And they've been creating cryptography for us and giving it to us and telling us it is strong cryptography and that it's a standard and that's all we have to worry about is using it. But that's not the kind of cryptography that they use to protect their own secrets. These are the same people that are paying for Tor and other, honeypots. So why would we think that this kind of cryptography is useful to protect us? And moreover, so there's quantum computing on the horizon, and it will be we may not know when it's in place. So what we want to do is use the kind of cryptography that nation states use, which is based on purely random functions, and that is inherently quantum resistant as well. So it's strong against conventional cryptanalysis, but it is also quantum resistant. So if we can meet these 4 requirements, we can make a messaging and payments platform that can be the next stage in the evolution of social media, right? We've seen like half a dozen or more stages. Every time it seems like the dominant players are irreplaceable. They're locked in forever, and then a new and better platform emerges, everyone moves over. Happens over and over again. So when we have a system up there that shreds the metadata and gives people control over their own informational lives, you can expect the public to follow the thought leaders here to using those new systems. So let me just real briefly, and I apologize if you've seen this before, show you this video which explains how the system works.
Message to Bob, but she doesn't want anyone to know that the two of them are communicating. Message content can easily be protected by so-called end-to-end encryption, but this does not protect the information about who's talking to whom and when, the metadata, which is increasingly recognized as far more revealing and more challenging to protect. Each member of a team of nodes, in order to protect the metadata, successively shuffles the batch of encrypted messages using its container of secretly arranged tubes and sending the messages without delay through to the next team member. Even just a single node can keep senders from being linked to recipients. Alice also gets a receipt informing her confidentially that her message was provided to Bob. Team members then destroy their secret pattern of tubes, making way for a new team ready for a new batch. Earlier, each node is chosen independently as a kind of random secret key, which input tube to connect to which output tube. Elixxr's breakthrough over the type of messaging I open sourced in the 80s is a way that enables almost all the work to be done well in advance, yielding the only known way to provide real-time metadata protection smartphone to smartphone. Lead can also pay Yumi by sending what appears to be an ordinary message, but that actually contains numbers that serve like metal coins and paper money. Called such denominated unforgeable numbers digital cash, first issued by DigiCash in the 90s. Elixxr's breakthrough improvement on the original digital cash now makes it fully distributed and quantum resistant. Elixxr thus is able to uniquely provide a new, ultimate metadata level protection of confidentiality in all your online communications and payments. For the first time, giving you a protected sphere, protecting your digital world today and your digital future.
So it's my great pleasure to introduce our stealth project Praxis, which here for the first time is actually able to deliver on the promise of the Satoshi white paper in the first words, a real digital cash that is not just a store of value, but is actually a way for people to make payments, and a protected messaging system that can support that we've already been working on. So the Praxis breakthrough is based on work I've done on consensus in my dissertation at Berkeley in '82, where I proposed the first blockchain actually, and the work I've done on voting, which the random sample voting is going to be very important in governance, and all the work on electronic money and so forth. And so the Praxis system can meet those 4 requirements that we discussed, and it does so in a quantum resistant way based on random functions only. So this is it's actually a totally new kind of consensus algorithm. It's a breakthrough in the whole approach to consensus algorithms, and this is necessary really in order to be able to provide privacy in messaging, because we need teams of nodes per batch of messages, and we need all those other requirements met. And so what Praxis does is it creates a consensus that's adequate for this, and it creates a new currency, sort of bringing our project up to speed with the rest of the community project. So we have, we're like thrilled to be able to announce this work, and we're just coming out of stealth, but when you see the white paper later this year, I believe you'll be able to read it and understand how the consensus mechanism works all the way down to the metal. And that's something I think few people are able to do with the existing white paper. So I'm hoping that you'll find that true and help us make that be the case. So this is the first meta, and the only real way to shred metadata that I'm aware of. It's full stack, totally decentralized, breakthrough blockchain technology. So that's what we're announcing here. But of course, it's all about community, and that's what I've been spending an awful lot of my time on, and we've got tremendous support, and we're thrilled about it. And we have several thousand people using our app, and they'll be starting to be switched over to the AlphaNet to help us really test it out and start using this new kind of messaging and prove out that it really does meet all the requirements. So we have this running on Android and iOS, and I hope that you have all got this on your mobile devices. We also have our local leadership program underway for our XX Collective. And so if you're interested in participating in that, please let me hear from you. And that's a central part of what we're doing. We've got actually a meetup tonight. We had one last night. We have another one tonight. And then we'll be in the UK next week, and so on and so forth. So that's our community. And let me just tell you a little bit about the AlphaNet, which is now working and will be available at the end of this month. It's actually currently running, but it's basically, we have a way we have client software so that the app will be able to send and receive messages as we let more and more users on. And we also have, so we're starting this new messaging system. That's quite a thing, isn't it? And so you could be some of the first users of it if you like. We also have programmatic access to the messaging. That is, we have a full set of officially supported libraries and APIs from basically all kinds of platforms. And we have about 20 or 30 people who are signed up, and they're in negotiation right now about the details to be the first users that we support in the use of this software so that we can perfect it and the documentation and all that. And if you're interested in being one of the first like dApp developers to run on our platform, please let us, there's a process for joining that program. We call it the Arrow SDK. And so it will involve, the AlphaNet will involve, as is shown on this slide, 8 nodes located around the world from different jurisdictions. They will not be run by us. However, if you think about it, as a prelude to a fully open distributed system, we need strong partners operating those nodes that aren't going to be at all controlled by us. So these will be run by independent entities initially, and then ultimately there'll be thousands, and so the hundreds of beta nodes, the 600 or 700 we have, will be running the network in the beta version. But initially, we're working with a limited set of partners that are sort of outside of our control. Here's just a quick demo of the Messenger, which is running on Android and iOS. And you can expect. So, yeah, here's the address to apply if you'd like to be participate in these in the program. And ultimately, this same these same APIs and libraries will support the DApp engine marketplace that we've developed. And I'm not going to have time to really go into that here, but suffice it to say that, interestingly, having an untraceable messaging platform like ours provides a unique opportunity to create a DApp engine marketplace where the dApps run off-chain, but they run in a sort of, they're hosted in fragments by anonymous members of the engine marketplace. And the ultimate unlinkability and untraceability of the messaging is the thing that makes that all viable, because the engines don't really know which dApps they're running, and the dApp can't really choose which engines are running their parts, and so on. And so this is so we know about this from the theory. Actually, there was a conference, a whole week at, I believe it was Oberwolfach here in Germany a few years ago, that were some of the theoretical results about if you have an untraceable sending system, what it means, what kind of computations you can simulate. It's actually a very powerful piece of infrastructure. And so that's what's going to allow our off-chain processing of dApps with a marketplace of DApp engines, unlike anything that's currently available. So this, importantly, those dApps will be able to keep secrets. So current DApp engines have a lot of trouble with that. And they're also kind of slowing down our chains, right? But since these are totally off-chain, and they're able to keep secrets and actually even persistent data, and the programming model is not a convoluted one, but a more straightforward one, where you're able to choose your own development environment and so on, this is going to do a great deal to make it easy for anyone to create real dApps and run them on this marketplace. And if you look, coming back to messaging integrated with payments, right? What WeChat has, what Alipay has, what Facebook is moving towards, and the other messaging systems, what they all have or want to have, and what's like WeChat in China, so-called mini apps, those are basically dApps. What users want, of course, is messaging integrated with payments, and then dApps in that same message space, in that same application, in that same API, in that same user namespace. So integrated dApps, and that's what we will be able to do. So it's quite an exciting opportunity to basically go up against all these big guys with something which is enormously better. And when it does take over, I think this could avert a lot of serious problems that society faces today with the misuse of our information. So just to tell you a little bit about our beta program, we have like 870 applications through a very open process where we started with a survey to find out what kind of requirements and criteria the community thought were best suited for the beta nodes, and sort of whole open process of application and vetting them and so on. Now we've put them into 3 teams. There's been a lot of interaction and discussion at the community, and so those beta nodes are very well distributed across the planet. And interestingly, also in a way that relates to the big pipes of the internet. So, more about that will be announced later. So let me just try to briefly summarize what the whole roadmap for our project has been and our trajectory. So as I said, just under a year ago, we announced Elixxr. That was at Consensus in Singapore, and now you can see that we've really delivered on what we said we were going to do then. And by the way, we've not sold any coins or anything to the public. I mean, we just did this on our own steam. And so now, this month, Praxis is coming out of stealth. You know, building a skunk works in the Cayman Islands, we couldn't find anyone else who's done that. But this gave us a huge opportunity to bring in the best people from all over the planet without governments being able to tell us who could come and work where. We were able to bring everyone there to work on it, and so that's where this breakthrough has taken place. We have the AlphaNet that's taken a tremendous amount of dedicated work to really build that out fully, and all the libraries and the SDK that makes it available to developers and so on. It's now in quite good shape, and then we've got the beta nodes all lined up, ready to start operating the BetaNet, and our XX collective is well underway, and now we're really counting on this community support and involvement to move the project forward. At the end of this year, I expect that the white paper will be published, and I hope you'll all have a chance to look at it, and I hope that you'll find it true, that you can understand how we're able to achieve consensus in this new model and why it's superior and how it actually works. And then we hope to also be able to launch the BetaNet, and then next year, based on all the vetting and testing and all, we hope to be ready for the mainnet launch, and we hope to have a superior and really nice governance system. And this is something that I think the DAOs and everyone could benefit from, because I've over the last half dozen years or so been working on this so-called random sample voting or sample voting, and I've received a lot of feedback from the so-called well, the whole voting community and the social choice world and so forth, and it looks like that no one has ever really proposed sample voting, and if you really look at it, it provides tremendously transparent and extremely fine-grained governance that's otherwise unattainable. So it turns out that if you can publicly, verifiably choose 1,000 participants at random, and they know that their votes will be counted accurately, and you give them a single binary choice, you can create a governance system that can handle thousands of these binary contests, and each one is like sort of like a jury where there are rewards, but not based on how people vote, and it provides a far more effective way to like vet code updates, make all this fine-grained decisions, but also set and adjust and adapt larger policy questions. So it's a really great system apparently, and it has a unique feature which is absent from all other governance and voting technology that I'm aware of, and that is that it prevents vote buying or coercion, so-called improper influence of voters. And it does that by the use of what are called decoy ballots. And so these are ballots that are freely available, but where there's a proof of decoy to the recipient of the ballot, but then they're encouraged to try to sell that vote, and the buyer will never know that it was an uncounted vote, but the recipient will, and this There's published articles on this now in refereed publications. This drives the price of bought votes down to nearly, to the point where the actual voters won't be tempted to sell their real votes. So if you want to have an online governance system, then I think we will have a super example of that for you. So let me thank you all for your attention, and I hope you have a wonderful time in here and this great event, and look forward to seeing you maybe tonight, Soho House. Thanks again.